All right, welcome back from spring break. I hope that you guys had a fabulous week off. Looks like we're still doing this online video thing, so here we go. Today we're going to be going over what I'm going to call 10.7b. We have made it through the parts of chapter 10 that we're going to touch on as far as circles. So make sure that we're really comfortable with each of those. We'll revisit them and see them on the mid-quarter exam in 2 weeks. Other than that, we're going to revisit parabolas again today. We'll talk more about this term conic sections that you see here next time. But parabolas, woohoo, we haven't seen them in a while. We spent a lot of time with them, and we are going to look at them a little bit. If we look at our learning target today, be able to use the vertex form. Let's remind ourselves about the forms of quadratics. This will be a good review for your end of year test as well. And then be able to graph both vertical, so we did a lot of vertical parabolas, right? Vertical parabolas, they open up or they open down. And today we're going to look at horizontal parabolas. And then we're going to talk about what it means to determine their directrix, so this guy, and the focus. Now we'll talk more about some applications that relate to these satellite dishes and other things like that as we go. But again, your goal today is to remember things that we've done in relation to parabolas and then be able to extend those to horizontal parabolas. I'm going to do this in 2 different videos. The first one will cover just the vertical horizontal parabola idea. The second one will cover the directrix and focus. So let's talk a little bit about what we do remember and then extend that to what we're going to learn today. So first, let's talk about the forms of quadratics. There were 3 forms of quadratics, right? The first one that we looked at looked like y is equal to a, and then we said x minus p and x minus q. That was what we called intercept or factored form. We liked that one because it was really easy to solve. It gave us those x-intercepts. The next one, if we were to multiply and distribute that one out, then we ended up in standard form. So we looked at standard form a lot, right? Had those coefficients of a, b, and c. And the last one, where we completed the square, and you guys did this a little bit with your circle equations, but you put this into vertex form, x minus h squared plus k, where hk, right, represented the vertex. So we always did the opposite of the h and k. That was the vertex. And then remember, this a value is the only thing really that was consistent in all 3 forms. And the a value told us a lot about the shape of the parabola. So we knew that all of them were parabolas. They made that U shape. But remember, if there was a positive a, then we knew that the graph opened up. So we always looked out front. If it was a negative a, then we knew that the graph opened down. So that was really helpful in determining what the parabola was going to look like. And then if that a value was, say, a 2 or a 3 or a 4, right? If a was greater than 1, then we knew that it was stretching it and it was making it really tall and skinny. So it changed that slope, it stretched it. And then if a was between 0 and 1, and I should be saying the absolute value of a, just meaning we already talked about the negative, then it shrunk it. So it was a shrink and it made it kind of wide. And we know that parabolas go up by perfect squares. So when we graph them, we would often plot the vertex and then increase it by perfect squares. Okay, so we're going to look at those today once again. So let's do one example of that and review that, and then we'll kind of come back to the others. So let's say it's given to us in vertex form. Now, some of them today you will need to complete the square. So remember, to go from this form to this form, you would complete the square. So we'll do an example like that just to remind you. So let's look at an example here where we are asked to graph y is equal to, let's say, negative x minus 1 squared plus 4. Okay, now remember, to graph a parabola, we would look at the vertex first. So we're like, okay, well, the vertex here is my h and my k, and I always do the opposite of h. So we know that the vertex is going to be at 1 and 4. So we liked identifying that first. We then look right here at the leading coefficient, and that tells me that it's going to open down, right? That's negative. So remember, we talked about having a frowny face parabola. That one's going to open down. And then notice there's not a numerical value greater than 1 out there, so this one doesn't have a stretch. So those are just some things that we want to observe as we look at the equation, okay? Then we're going to go ahead and graph this. So I don't know how this is really going to go, but maybe it'll help me draw my straight lines. Yikes. Oh, not bad. Okay, we're going to put some tick marks on here. 1, 2, 3, 4, 5. Maybe I should label that a little. 1, 2, 3, 4, 5. 1, 2, 3, 4. So we can draw our graphs. Once we've done that, again, we're just going to plot the information that we're given. So the vertex was 1, 4, so I'm going to go over to the right 1, and I'm going to go up 4, and I'm going to plot that vertex. There's the vertex of my parabola. Then the second thing is I'm going to graph it. So remember, if it hasn't been stretched, we use perfect squares to graph this. So if I'm 1 unit away from my vertex, either direction, 1 unit away, 1 squared is 1, so it's going to move 1 in the down direction because we knew it was opening down. Now if I'm 2 units away, so we're 2 to the right, okay, now I'm just making lots of dots. 2 squared is 4, so we know that that one is 4 units away from the vertex down, so we know that it's going to look like this. So essentially we can draw our parabola here. We know it's opening down. Hasn't been stretched or shrunk, but it would look something like this. Okay. Now let's talk about, well, what would happen if instead our parabola looked something like this? So what if we wrote this as x equals, let's still use a, and let's say it's y squared plus b times y plus c. Now just for a minute, I want you to compare those two equations. Notice the only thing that's changed is the x and the y's switch spots. So now we've got x over here, and the y is the variable that's in the spot on the right. Okay, the rest of this looks the same, your a, b, and c. We could also write vertex form, switching those around. So notice here, we've got x equals, a is again in its own spot, and then I could put y minus, now y is always related to the k value of the vertex, so I'm going to put the k in there this time, and this time the h has to go on the outside. Notice the x and y just switch spots, but because they switch spots, your h and your k also switch spots. Okay, now these parabolas, when your x and y switch, they create horizontal parabolas. So the A does exactly the same thing. It tells you what side it opens, but this time it's going to open left or right. Now on an x-axis, and I'm going to use this graph to just kind of remind us, but here's our x-axis. Remember, positive is in the right direction on the x-axis, negative is in the left direction. So if this is a positive A, then I can assume that my graph is actually going to open to the right. If it's a negative A, it's going to open, that's also to the right, how confusing, to the left. So we're looking at something like that, okay? Now the stretch and the shrinks actually work the same from our vertex, so I'm not going to rewrite those out. But just again, when you're identifying that vertex, just remember, this is the part that always tricks me. This H still is that piece, and the K is that piece. They're just in different spots. So this time we do the opposite of K, right? We do the opposite because it's coming out of that parenthesis. We still want HK there. So let's look at one of these, very similar to the other one that we did. And let's look at another example. And let's say that we're going to graph, okay, but this time it's x equals negative y minus 2 squared plus 3. Okay. Again, we want to identify the same things. So let's say, okay, well, what would the vertex be here? Well, immediately I notice my x and y are switched, so I'm like, don't get tricked. My k and h are right there. So my vertex here is going to be 3, and then again I switch this sign because it's coming out of the parentheses, so that becomes a positive 2. Okay. Then we look out front and we look at this value out here and notice it's a negative. So remember, we know it's going to open to the right or to the left, but because that's negative, this one is going to open left. Okay, so we know it's opening left. And then there's not a value greater than 1 in the front with that negative, so there's no stretch on this guy either. Okay, so let's go ahead and see if we can graph this one. So again, I'm going to draw my two axes here. Oh man, it didn't help me at all, so that was great. Oh, there we go. Let's draw some little tick marks here. Okay, sometimes it's too helpful. Okay, too helpful. I'm going to mark some of these. It's just helpful. Hint, hint, when I'm grading. Okay, as we go through this, so the vertex is at 3, 2. Okay, so I'm going to plot that. So I'm going to go over to the right 3, and then I'm going to go up 2. Oops, now I left a little string thing there. Right there. And that's going to be my vertex. I know that it's going to open to the left. So again, we do actually the same thing we did on the other example. If I'm 1 unit away, now this time I'm looking 1 unit away, I'm going to be 1 unit forward. Because 1 unit away, 1 squared is 1, right? So we're looking at that. Again, if I'm 2 units away from the vertex, 2 squared is 4, so I'm going to go here. And again, 2 squared is 4. We know they're symmetric, so that's kind of nice. Okay, I don't know why I can't find this dot. There we go. All right, then we can draw our horizontal parabola. Okay. Essentially, that's the gist of it. I'm going to do one more example where we need to put it into vertex form. So you can work through this. If you feel like you have it, you're good, run with it. Again, you're just practicing graphing this in vertex form. So let's say we have this one, and let's say that it's given to us as graph y is equal to 3x squared plus 36x plus 103. We're going to walk through the steps. Again, we look for a greatest common factor. Now, you can't just divide it out of everything. You're not solving. It's equal to y. So we would do y is equal to, and we pull it out front. We get x squared plus 36 divided by 3 leaves us with 12x. And remember, when we complete the square, the 103 is just hanging out on the end there. Okay. Then we're looking for that perfect number right here. So if we want to find that perfect number, we take half of 12. Half of 12, right, is 6, and then we square it to find that number. So this is like plus 36. Now, remember when we did this, you have to account for this 3 out front. So you didn't really just add 36. Really, because you put that in the parenthesis, you added 3 times 36, which is 108. So if you added in 108, then you need to make sure you subtract 108 to keep things balanced. Okay, then we finish completing this square by factoring this piece. So we do x, that would be x plus 6 and x plus 6. Remember, we could write it like this, both of them, but we put it together, x plus 6 squared. Then we combine those numbers on the end. 103 minus 108 is negative 105. Okay. So then we could plot this. Oh, not 105. I'm so sorry. See, I need you guys to hear checking my work. Okay, then we look at this one and we can graph it just like we have been. So again, you want to find the vertex. The vertex here comes from our HK, so we do the opposite of the inside value, the H, and then we keep that K value. Notice again, this one's going to open up or down because our X's and Y's are in those normal spots. This one's been stretched by 3 and it's positive, so this one's going to open up and it's going to be stretched by 3. Okay, so again, if we're going to draw this, we could go like this, we could go like this. Draw some tick marks here. This one's going to get big real fast, so we'll see if we can even fit it on here. Yikes. Oh, these are getting real messy. Okay, the vertex is at negative 6. Negative 5. I don't even know if I went that far. Okay, 1, 2, 3, 4, 5, 6. Yes, negative 6. 1, 2, 3, 4, negative 5. So right there. is my vertex, and it's being stretched up by 3. So if I go 1 unit to the right of the vertex, I need to go up. Instead of just 1, right? Normally it's up 1, because 1 squared is 1. We're going to go up 3. Okay, so remember we make that symmetric. Then if I move 2 units away from the vertex, usually it's up 4, but we're actually going to go 4 times 3 because it's stretched. So that guy's going to be up 12. So we're going to be clear up at 7. 1, 2, 3, 4, 5, 6. Yikes, clear up here where I didn't draw one. 7. So you're looking at a very steep one on this guy. The best you can, make sure that vertex is in the right spot. Okay. Oh, not too bad. All right, last one. Again, if you feel comfortable with this, you're welcome to just proceed forward. Stop watching at any time. All right, x is equal to y squared plus 12y plus 34. Notice again your x and y's are in different spots, but that's okay. We're still going to complete the square. So we start with x is equal to, all I'm going to do is move the 34 out of the way because there's not a greatest common factor to divide out. Once we do that, oh, we actually have a 12 again. Great job choosing an example. So again, that perfect number, half of 12 is 6, and 6 squared gives me that 36. This time, right, there's nothing multiplying in. I just added 36, so now I need to subtract 36 off the end. So we end up with x is equal to y plus 6 squared, and 34 minus 36, it looks like, is -2. Okay, so if we want to graph that, again, we do the same things we've been doing. We look for the vertex. Now don't get tricked. This vertex is backwards, hk, so it's going to be -2, -6. Again, that 6 is negative because it's coming out of that parenthesis. And we know that this one's going to open to the right or the left. Notice if you look out front, it's a positive value out there. So this one's going to open to the right. Okay, maybe I should just write the word right. Okay, open to the right. And there's no stretch, right? So I'm just kind of making some mental notes so that when I graph this. Okay, and then again, you're just going to plot these. So here we go. Oop, oop. Do you guys wish you had one of those tools? All right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right. -2, -6. So I'm going to go left 2, down 1, 2, 3, 4, 5. Oh, that was right where I got to. -6. Let's make a couple more marks in case we need them. All right. Then it hasn't been stretched at all, and I know it's opening to the right. So I'm going to go 1 unit away from the vertex is going to be 1 forward. 2 units from the vertex is going to be 4 forward because we're looking at 2 squared, which is 4. So here's my parabola opening to the right. Again, that's a lot of examples, but I just wanted to make sure that you had enough to work through this. Don't shortchange yourself. Make sure that you work through, identify that vertex, recognize where's my x, where's my y. Up, down, right, or left are all options at this point.